Clear cutting. Let's talk about it. Man, that's a devastating picture, isn't it? So, in 1990, my wife and I moved to Washington State from Columbia, South Carolina, where we met in graduate school. And we had high expectations of what the Northwest was going to look like. And we knew it had these amazing, what are called old growth forests, that it was just supposed to be one of the most beautiful places in America. And it is. And they have these things that really, I mean, if you go to college in Seattle, you'll be amazed at the kind of forest that you can encounter there. But as we were driving there, when we were coming over the last mountain pass, it's called the Cascade Mountains. It's a volcanic mountain range, coastal mountain range, and right on the other side of it is Seattle. We're coming over. It's called Snoqualmie Pass, and what we saw really brought us up short. What we saw was our first clear cuts. This is what we saw. We're like, this beautiful, beautiful area that we've been dreaming of for so long is scarred. All the trees are removed from the mountains and just in strips of forest just gone. And so that was our first abrupt introduction to this concept of clear cutting. And it is definitely a major factor in how we use land resources. So let's just talk about why it happens and what its impacts are. So, look, as long as humans have been humans, we have understood that wood is an incredibly useful building material. Going all the way back to prehistoric times, people have used wood for fuel, but they've also used it as a building material and to make furniture out of. And so this history of humans cutting down trees and then using wood products for construction purposes is basically a deeply rooted part of who we are. We love wood. I mean, if you've ever been to Kyoto and you go into these beautiful temples that are made out of wood that's like hundreds or 1,000 year old, there's just something really cool about that, right? Humans like wood, okay? Uh, but you got to get it from somewhere, right? So that means you got to go out in the forest and you got to chop down trees. And what do you do with them? Well, you can make construction project products out of them, but you can also make other things. So paper products, cardboard, newspaper, books. Uh, I'm sure it's not news to you that paper comes from trees, but in order to get that product, you've got to cut down trees, right? And so uh, there's it's a substance that's valuable, right? It's a commodity that we want, and so people are going to find the most economic way to access that resource, and that's where clear cutting comes in. So prior to clear cutting, in the state of Washington, where I come from, if you walk in the forest, you'll see stumps of trees. You want to see these old people; they're gone now. But you'll see this how they put like these notches in here, so they could stand here. So they had a place like it's too big to cut the tree down here, so they would go up about 10 feet and cut the tree there. This is a beautiful, what we call old growth tree. And here's a person who's in the process of cutting it down. And as you can imagine, if we cut this way, it takes a long time. So the traditional way of harvesting trees, and still the ecologically best way, is called selective cutting or selection cutting. And basically, what that means is you select the tree you want. You go in the forest, you're like, "Oh, that's a tree I want to cut down." And so you just pick that tree, you go in there, you cut it down, and then you got to get it out of the woods. And there's the problem. Okay, so yeah, you can go in and pick the best tree to cut down, but now how are you going to get it out of the woods? So there's probably isn't a road nearby. So if you try to drag it, then there's all these other trees in the way. So the thing about selection cutting is, yes, you're only taking down certain trees and leaving the rest of them intact, which is better for the ecosystem. However, it's really expensive because it's hard to get the tree you harvest out. Well, people came up with another idea, and that's called shelter wood cutting. So shelter wood cutting, basically the idea is that the shelter wood is trees that are left standing to provide shelter in the sense of shade so that the younger trees can grow. So the idea is I'm going to cut down a lot of trees, not just a few trees. So it makes it a little bit easier to clear the land out. But the main thing is that I'm harvesting more product from a given hectare of land. So I'm making more money. But I also understand that I want to keep making money on this land. So I want trees to keep growing. I want to be able to come back every few years and harvest more trees, which means I got to leave some of them in place. So those trees that are left in place are shelter trees. We call it shelter wood harvesting. And one of the good things about it is these trees that are left in place will continue to reproduce. And so the seedlings will get started in a natural way. and they can be left there. Because if I cut all these trees down, I just got to replant them, right? Which is where clear cutting comes in. So starting in the 1800s, people realized, well, if you really want to make money, and this is after the railroads became a thing, right? So once railroads were in place, then people were like, well, wait a second, I can make a lot of money by chopping down a lot of trees and moving them to cities back, say in the eastern part of the United States. So people came up with the most economically advantageous way to do that, which is simply to chop down everything there, like just scrape it down. And one of the reasons this is economic is, first of all, you're getting more product off the land, but also it's easy to move things. So like you start here, you just kind of move your way out, and every time you cut something down, you just move it, and you just build a road right through there. And so it makes it really easy to transport things out of there. So it is economically a no-brainer. If you want to make the maximum money off this land, you cut everything down. We call it a clear cut, and it's easy to transport. So you did have to spend a lot of money to get the product. So you're maximizing your profit. Now, obviously, this land isn't going to be reused anytime soon. Now, people do go back and replant trees afterwards, but it's going to take those trees a long time to get back to anything like that. Okay, but anyway, that's clear cutting. Okay, so obviously, it's if you're an animal that lived there, you probably don't live there anymore. Okay, so clearly, it is a major ecosystem disruption. Basically, secondary succession is going to happen, although we facilitate that by planting trees. So any animals here, they've got to move over to other place. Uh, but you can obviously, like, habitat loss is a no-brainer. I don't even think I really need to talk about that. But there's other things about it that we need to talk about. Oh, I didn't realize I had this slide going. So this basically is just showing how you got a road here. So you chop the trees down, you put it on the road, carry it away. So it is worth noting that clear cuts are often in modern times happening on forested hillsides, and the reason is the lowlands, the valley bottoms, where there was less steepness to the slope. These trees were harvested long ago, and so there isn't as much profitability in the trees that are left because we've already cut them down once or twice. So in recent decades, people started moving up the hillsides, and I mean, you can we've talked enough about it. You can see where this is going, and it's not good. Okay, now listen. Everything changed a few years before my wife and I moved to the Northwest, and that's because there was advancements in technology. And we'll see this again and again. We see it with overfishing. When there is an improvement in technology, like in fishing, long line fishing, or these nets in the ocean, um, you end up greatly accelerating your profitability, but also you accelerate the rate at which the uh, destruction occurs. So it just makes it much harder for nature to recover from the damage that we do. So prior to the 1980s, this is how you harvested trees. You'd go out there with a chainsaw and you chop down this tree. Very dangerous work, but it takes time to cut down a tree this way and to move a tree like this. But in the 1980s, they invented new technology. They made these weird machines that could go. These trees can literally just grab a tree and just cut it and then pick it up and move it. And so, like, what used to take maybe months to harvest a section of woods, you can do it in days. So, of course, once if you invest in this kind of equipment, you want your money's worth. So, clear cutting just took off like crazy. This is a map. So the house that my wife and I own, let's see, is right up here in a place called Silverdale, Washington. Okay, this is known as the Olympic National Park. It's something of a treasure in the United States. Uh, Now, a national park, and we'll talk about this at the end of this video, is basically a section of land that's set aside by the government. We say, look, we are not touching this. It's a beautiful idea. Korea has, I think, 40 of these. It's a really great idea. But outside the park boundaries, people are allowed to harvest wood. The orange is every place where people have clear cut. And they've clear cut so much you can clearly see the outlines of the national park. So people just quickly just chopped down basically every tree that was there. And then the loggers went out of business and they blamed the environmentalists for setting aside the Olympic National Park. But let's face it, this is not sustainable. Okay. So if you harvest a product faster than it can replenish, you're not going to get it back. That's not sustainable. Okay, so if you did shelter wood or selection harvest, yeah, you could basically keep harvesting this forever. But when you start doing clear cutting, you just zip through it really quick, and then you chop this down. You got to wait 150 years before you can cut it again. That's not really sustainable. All right, but let's just talk about apart from the lack of the impact it has on cultural ecosystem services. We look at it and we feel sad, which, by the way, they try to protect us from that. You drive down the highway and you may not, if there's not mountains, you may not even know there's clear cuts right next to the highway. They leave a barrier of trees between you, like a buffer zone of trees between you and the clear cut. And it's not for ecological reasons. It's purely for cultural ecosystem services. It's just like, wow, I'm not feeling sad about the destruction of the ecosystem because I'm not seeing it. Okay, you get up and there's a company, what do they call themselves? I forget, but basically what they would do is in the 80s when this was happening, they would take members of Congress and state legislatures in airplanes and they'd fly them over the Northwest and say, guys, from the ground you don't see it, but from the air, look at what's going on here to try to get people to understand the impact that this was having on the ecosystem. Now, so part of destruction of habitat, what are some of the problems caused? Well, there's a lot of problems caused by clear cutting. Okay. So I'm going to zip through it real quick and I'm going to talk about each of these in turn. So obviously, if you take away vegetation, there's going to be increased runoff. When there's increased runoff, there's going to be increased erosion, and that sediment has to go somewhere. It goes in the stream and it increases stream turbidity, cloudiness of the stream. Again, if there's increased runoff, then in a big rain event, there's going to be flooding. So it increases the amount of flooding. In fact, I used to amaze my students by making prediction. I'd be like, I think there's going to be a flood on the Skokomish River on the second week of November, like right on the board. I do this in August. And it would happen to be like, how did you know? It's like, well, because that entire watershed has been completely clear cut all the way up to the divide. There's basically no vegetation there. So when it rains, it floods every single time. Now, that means that nutrients are going to get leached into the streams, and that's going to impact the streams. It turns out that's going to cause the pH to go down. We'll talk about why. The temperature of the streams are going to go up, so it has a major impact on the aquatic ecosystems. There's also going to have less oxygen dissolved in the water. The soils themselves in the land that's left behind after the clear cut are going to lose moisture through evaporation. The regulating ecosystem service that the trees normally provide is going to be gone, so the temperature swings will be very large, and it will also change the amount of precipitation we have in the air for lack of transpiration. So let's just take a look at this. Let's start off with this. Okay. So if you take away the vegetation, when it rains, remember, the water, instead of infiltrating into the ground, it comes down too fast for that. Infiltration takes time, so it flows across the surface as surface runoff. And when that happens, that water quickly ends up in streams. And so in a rain event, in an area of a lot of clear cutting, floods are very common. Oops, I didn't mean to do that. So floods are going to be very common, which has an impact both on people and on the ecosystems of that aquatic environment. Now, when water is moving down a hillside, it carries sediment with it, so we get erosion. So erosion is a very common problem after you have a clear cut because the water's just flowing fast, and when water flows fast, it picks up soil and moves it. Now, that soil is going to end up in the water, so the turbidity of the water increases tremendously. So the streams have a muddy look afterwards. So you can see that they're just transporting a lot of that sediment into these river systems and the lakes that they might go into. Another thing that's going to happen is that normally there is a nutrient cycling happening with trees, right? So nutrients go up into trees, and the trees lose their leaves or their needles, and then decomposition happens, and then ammonification happens, and then nitrification happens, and it goes back up in the tree, and it cycles. And slowly, materials, especially phosphorus, might move downhill, but it takes a long, long time. But all of a sudden, now without the tree, everything here is just washing downhill into the stream. So basically, all the nutrients that are in the upper layers of the soil, they get transported with the sediment. So those nutrients get leached or removed from here and washed away to the stream. So what's left behind, the soil that's left behind, is very low in nutrients, which makes it hard to regrow trees afterwards. And by the way, those nutrients, when they end up in streams, are going to cause a problem called eutrophication. Now, eutrophication in the course exam and description that College Board gave us for this class puts it in the last unit of the year, but it's something I just want to touch on right now. And the idea is this: if you put a whole bunch of nutrients, say phosphorus and nitrates, into a stream, well, productivity is going to go up because now the algae has access to all these nutrients so they can build cells. So you might notice this, what is called an algae bloom. The water turns green with algae. There's so much of it, right? What do you think? Productivity, that's a good thing. But algae are single-celled organisms for the large part. And so the ones on the surface are doing great, but they're outcompeting the ones underneath them, and those ones die. And when they die, bacteria eat them. Well, when bacteria eat things, by the way, the bacteria population goes up because there's lots of food. Well, bacteria are consumers, so they are going to respire, which is going to take oxygen out of the environment, right? So what happens is when you dump large amounts of nutrients into an aquatic ecosystem, this process of eutrophication takes the form of first initial explosion of algal growth, followed by the death and decomposition, and then bacterial consumption or decomposition of these dead algae, which then causes the oxygen level in the stream to just plummet to the point that high oxygen consuming organisms, vertebrates, fish, and reptiles, they end up dying. Mostly fish. Obviously, the reptiles are going to breathe air, but they need to eat the fish, so they die too. All right. Now, the other thing that happens is this: it's going to change the pH of a stream. Why? Well, if you recall, when we talked about acid rain, we said, look, the rainwater might go in. Remember, normal rainwater has a pH of about 5.6 because of its interaction with carbon dioxide in the atmosphere. As it moves through soil, though, as it infiltrates the soil and percolates down, it basically is buffered by reacting with minerals in the soil. So when it finally is discharging out of the ground and into a lake, so recharging a lake or recharging a stream, when it exits the ground, it becomes surface water once again. Its pH has been buffered tremendously. It goes in at 5.6 and it might come out at 6.5. So that's a significant, tenfold reduction in the hydrogen ion concentration. Well, if it doesn't go into the soil, then those minerals don't buffer it. So it just comes down the hill and it's 5.6, right? So basically the pH of the streams goes from 6, almost 7, down into the 5s, and that has an impact on many species of organisms, mostly vertebrate species. So it definitely causes fish kills. It causes the death of a lot of amphibians. All right, get the message, man. Clearcutting is bad news, okay? Well, it gets worse, okay? So ordinarily, in a healthy ecosystem, these streams are existing under the shelter of overhanging trees. And even if the trees don't overhang, they still provide a lot of shade, all right? Now what happens though is if you cut down all the trees, then these streams don't have any shade anymore. And so what's going to happen? Well, the temperature of the water is going to go up, obviously, right? So if the sun doesn't shine on it, the temperature might be, say, let's just make it 12, okay? The sun's shining on it, it goes up to 25, 30, right? Well, that's a big change in temperature, okay? So changing the temperature of a stream is not good because a lot of the organisms that have evolved to live here are very dependent on certain temperature thresholds. Now, one of the main problems that we find when we increase the temperature of water is that gases are less soluble in warm water than they are in cold water. So this graph is pretty telling here. So dissolved oxygen, or DO as we call it, is crucial for aquatic life. And so you can't breathe if there's no oxygen. So water dissolves oxygen. Oxygen dissolves into water. And so we see this, look, when the temperature is like below 10, I might get, say, 12 or more milligrams per liter dissolved in it. But as it warms up, the amount of oxygen that can stay dissolved in it plummets dramatically in this inverse relationship. So as it gets hot, I basically cut the oxygen levels in about half. I mean, if we took half the oxygen out of the air, we would all be dead. Okay, and so what happens is you increase the temperature of these streams, you cause a lot of fish death. It keeps getting worse. Now I got these soils that are exposed. We'll leave the streams for now. The soils that were under the trees are now, first of all, they've had the humus washed away into the streams. Now the soil is just exposed. The sun shines on it. Well, what happens is the moisture, and remember, the majority of the the freshwater planet that's not in glaciers is in soils. Well, guess what? The moisture in those soils evaporates out, and now this ground kind of gets baked. And basically, what does that do? Well, a lot of the bacteria in here that's really nitrogen fixers, they die, and so the soil is very, very much degraded in terms of its nutrient level and its ability to be fertile. Okay, so the soil that we just count on is now not really suitable for growth anymore, and so that makes it more likely to erode in future rain events. And of course, if there's not much vegetation here, so the productivity in the area is going to go down. Apart from the fact that it's hard to get things to regrow, which is without trees, without plants, because they pretty much take everything. There's not going to be much productivity in here, and so well, all right, well that's obvious, but what does that really mean? Well, keep in mind, productivity is the photosynthetic act of taking solar energy and taking that energy from sunlight and using it to construct glucose. So remember, first law of thermodynamics, you can't create or destroy energy. Energy comes in as light and it gets stored as chemical energy in glucose. Well, if that's not happening, you can't destroy that energy. That energy hit the earth. What's it going to do? Now, some of it will bounce back into space, is what we call albedo. Okay. But a lot of it will just get turned into thermal energy. The molecules in the ground are just going to vibrate faster. And so basically, we've changed the climate of the area, right? So it's going to get hotter now when the sun shines on it than it used to get, all right? Which is of course going to accelerate the rate at which the soils dry out. Uh, but it's also going to do something else because trees and other vegetation undergo transpiration, and transpiration puts moisture back in the air. If you look at that, one of the first pictures I showed you when I talked about my wife wanting to come to my wife and I moving to Washington, you could see the transpiration coming out of that forest. Well, with no forest, there's no transpiration. So not only am I changing the temperature of the air, I'm also changing the amount of precipitation here. So I literally totally changed the climate. If you look at the climate graph before and after a clear cut, you can see a distinct difference, right? Less precipitation, greater temperature. Another thing that happens is it leads to forest fragmentation. Remember, we talked about biodiversity. We talked about like if you could preserve lands, what would you preserve? So this kind of like this is it in reverse. So rather than having areas of forest that are separated, we have a contiguous area of forest, but now we're fragmenting it by taking out these clear cuts, and so animals that live in here, especially ones that have to have like a a large like bears and mountain lions and certain bird species, they need to have a large area of territory in which to look for food. That becomes severely limited now, and so it puts a lot of stress on those ecosystems. And so we find that there is a consequent reduction in biodiversity because we've already said that in order to maintain biodiversity, you need to have these continuous areas of forest. Now, how do you fix this? Well, really, again, it comes back to that tragedy of the commons. If you don't have any regulations, you don't have any forests because people want to make a profit. It's just the way we are. It's in our DNA. So without governments to say, hang on, you can't do this, it would all get cut down. This whole area here, which literally is a precious part of the United States, it would just be bare. I mean, those machines would just go all the way up to the glaciers, right? Because there's money to be made. All right. And you can see, like, this is all the clear cuts. This is the Olympic Peninsula from space, and you can clearly see the outline of that national park. The clear cuts go right up to the park boundary, and this part here is set aside. So basically, governments, and the Korean government's been very good about this, they've set aside quite a bit of the Korean Peninsula as national park. And so in the United States, we have various designations. You could be national park, uh, which has the intent of preserving nature and giving people a chance to access it. We have wilderness areas, which basically there's no roads, there's nothing. This is just to have biodiversity. You're allowed to go there, but we're not going to make it easy for you to go there. With the national park, we're going to make it easy for you to go there. You have national forests, which is a lot of America's national forests, especially the West. National forests, basically, the Forest Service is tasked with facilitating mining operations and logging operations, but also trying to maintain uh, people's ability to go and fish in the area, for people to graze animals in the area, for people to enjoy just being out in nature, cultural ecosystem services. So basically, it is incumbent upon governments to protect us from ourselves and the tragedy of the commons by setting aside large areas of contiguous land that's not fragmented. And fortunately, this idea, which started in America, actually, I think Teddy Roosevelt was one of the first people who suggested this back in the late 1800s. It has spread across the world, and most nations now have done a good job of setting aside significant parts of their country to just protect. Now, I'd like to talk about the term old growth forest. So, old growth forest, which is common in the Northwest where my house is, it's also called primary forest or virgin forest. Basically, what we're saying is this is a forest ecosystem that has not been cut down. All right. So these trees are the way that it's not just about trees, by the way. Forest is an ecosystem, right? So it's everything involved there. And so these basically the glaciers retreated from Washington State 10,000 years ago. So for 10,000 years ago, uh, primary succession occurred as the bare rock was exposed after the glaciers left. And after 10,000 years, here's what you have. It took 10,000 years to get to this. And if you chop it down, you can get a forest back, but it's not going to be the same ecosystem. So these old growth forests, these virgin forests, are very important for biodiversity. They took millions of years of evolution to arrive at, and if you cut them down, you just can't have them back. They cannot really be replaced, at least not in a human lifetime. So they're basically, you can think of a primary forest as a non-renewable resource. A forest is a renewable resource. You chop it down, it grows back, but it doesn't grow back the same way. It grows back very much altered from what you started with. And so you can't have it back. So that makes it a non-renewable resource. So when you plant it back, you tend to get tree farms. Yeah, a tree farm is not, I mean, it's a forest, I guess, but it's certainly not, it's not a natural ecosystem, right? It is very altered, and it doesn't in any way come close to replicating the biodiversity and the stability of the ecosystem that pre-existed the harvesting of all those trees. So logging companies will talk about, well, we replant. Okay, well, yeah, you're replanting. What you're getting is a tree farm, but you're not getting, the forest that you took away from us. Now, look at this. I mean, this is sobering and sad, and it's not quite accurate because I know for a fact that we have some old growth forest here. But basically, when Europeans arrived in the Americas, this is how much old growth forest there was. And over time, we took it down for using it as wood and to replace it with agricultural land. And even at the beginning of the 20th century, there's still a bit of old growth forest left, but now there's so little left. And the only thing that's left is set aside by the government. So, anyway, and by the way, there is no old growth forest in Korea. It's very hard. There's a little bit in some really remote parts of China. There's a little bit in Southeast Asia, but most old growth forest has been taken from us, and it is something that needs to be protected. Unfortunately, most governments now understand it and are protected. Why? Because you have environmental scientists who help people understand the need to preserve it. Okay, so sorry for this long one. Thanks for watching, and hey, let's get through this holiday season, huh? Sorry you had to watch this today.